In combinations, we learn about choosing the total number of ways in which R objects can be selected from the total of N objects. So let NCR denote the number of ways in which R objects can be selected, can be selected from total of N objects, Then what will be the total number of permutations? Then NPR, the total number of permutations, will be equal to NCR. These are the number of ways in which you can select R objects time R factorial, because within each group of R objects there are R factorial permutations. So this means if we choose to take or isolate the value of NCR, NCR would become equal to number of permutations divided by R factorial. And if we substitute NPR by its formula, this would be N factorial divided by N minus R factorial time R factorial. So this is how we can in fact calculate NCR. The example is find number of ways or evaluate 10C8. If we want to evaluate 10C8, then according to the formula, since NCR is equal to N factorial divided by N minus R factorial time R factorial. Here N is equal to 10 and R is equal to 8. This implies that 10C8 will be equal to 10 factorial divided by 10 minus 8 factorial time 8 factorial. So if that is the case, this is equal to 10 factorial divided by 2 factorial time 8 factorial. If we open this up, this will leave behind 10 times 9 divided by 2 times 1, because up to 8 factorial we can cancel it out. And this will give us the answer 2 5 times, and the answer would be 45. And we read it as 10 combination 8. This is how we can find out. And now let's do another example here. It's given that we now have to prove NCR is equal to N factorial over R factorial time N minus R factorial. That's what we have proved. But in order to prove that NCR is equal to NC N minus R, let's expand both. So to show example, to show that NCR is equal to NC N minus R, let's expand left hand side. Left hand side is equal to NCR which if we expand will become n factorial divided by n minus r factorial time r factorial. But if we switch over places, or even if we want to write it as 1 and also right hand side expansion is made, that is nc n minus r. So if we expand this one, this will become n factorial over n minus r factorial time n minus r factorial according to the rule. So this will become equal to n factorial over n minus n plus r factorial time n minus r factorial, and this is equal to n factorial over r factorial time n minus r factorial. And if we switch over the places, this will become n factorial over n minus r factorial time r factorial, and this is exactly what is value of nc r from equation 1. From equation 1. So this is nc n minus r. That's how we can prove it. There is one more question here which says evaluate tan C3, and there is another example, nc8 is equal to nc12, find n. If nc8, example 3, if nc8 is equal to nc12, then find n. Now since nc8 is equal to nc n minus 8, according to the formula ncr is equal to nc n minus r. If we use this formula, we can write nc8 equal to nc n minus 8, that is 1, but nc8 is given that this is equal to nc12. So this is, let's call this number 2. And if we compare right hand side of equation 1 and 2, comparing 1 and 2, we have n minus 8 equal to 12, and if that is the case, then n is equal to 12 plus 8, which gives n is equal to 20.